Good morning to all. This is A. Manikirao, lecturer in economics, working in Andhra Pradesh Residential Junior College, Nagarjuna Sagar. So today we are going to discuss about the second year economics, that is national income. National income. So before we are going to explain this topic, let me ask you few questions. So where does your parents gets incomes? Where does your parents gets incomes? What is the source of income for your parents? What is the source of income for your parents? You might say that, sir, our parents are employees. Our parents are employees. They are getting incomes. Out of their incomes, they give us money. Whatever we want, we purchase. Whatever we want, we purchase. Our parents are agriculture farmers. They are getting money from agriculture sector. They are getting money from agriculture sector. We are getting money from our parents. Whatever we want to purchase, we purchase. But as an individuals or as a students, you have any incomes? You have any incomes? You have any source of income? No, we don't have any source of income because we are not engaged in any work. We are not engaged in any work because we are the students. Still, we are studying in different classes. We are studying in different classes. We don't have any money. But we need money to purchase something what we want. We need money to purchase something. So, national income, it is very important concept in our second year economics. So, income for an individual, it is an important. Or income for a household, it is an important. Income for a state, it is very important. Similarly, income for a country, it is very important. Without incomes, individual cannot exist, household cannot run their family, state government should not run the economic activities, even central government or any country, they cannot do any welfare things for its people. So therefore, income is very important concept. Without income, there is no economic activities. Without income, nothing. So we need incomes. So here, our topic is national income. National income. So as we know that the rising national income, it is an important goal for a country. Rising national income as an important goal for a country. The economic welfare of a country depends upon what type of goods that are available to the purchase of its people. The economic welfare depends upon what goods and services that are available in the market for the consumption of its people. So therefore, the economic welfare of a community can be measured national income. The economic welfare of a community can be measured national income. So as we understood that national income is an important economic indicator. So national income it is a mirror. National income it is a mirror. If we see the mirror, we would see that how our face is, how our body is. Mirror, it explains. Mirror, it can't anything, it can't say anything, but it can be reflects how we are. If we are stand before mirror, what it says, it simply reflects what we are. The same way, national income also, it is like a mirror. Which sector is performing well? Which sector is performing well? Because every country broadly classified into three sectors. That is agriculture sector, industrial sector, and service sector. Agriculture sector, industrial sector, and service sector. Already developed countries, there depends upon service sector, little bit to industrial sector. Whereas the developing countries or underdeveloped countries, they depends on agriculture sector primarily, then little bit on industrial sector. But nowadays, every developing country, even underdeveloped countries, they are trying to give importance to service sector, because service sector contributes a lot to the national GDP. Service sector contributes a lot to the India's GDP. So therefore, every country, they have to give first importance to the agriculture, industrial sector, then service sector. But in all the countries, irrespective of developed countries and underdeveloped countries or developing countries, service sector is the forefront. Service sector is the very important sector for economic development. So, in this chapter, we are going to discuss what is national income, what is the meaning of national income, what is the definitions of national income, and what are the trends of India's growth rate of national income. What is the trends? India's growth rate national income. Then coming to income inequalities. Income inequalities. Income inequalities, how it exists. As we know that all the individuals are not the same. All individuals are not in the same. Because every individual, they are differ from other persons. Every person is different from other persons. In terms of size, in terms of color, in terms of tastes, preferences, educational qualifications, attitude, aptitude, all these things are different from one person to other persons. Here, inequalities, income inequalities, why it existed? What is income inequalities? What is the meaning of income inequalities? What are the different reports conducted by different institutions, research institutions, and how they have estimated national income? Top 10% of people, what is their income levels? And the bottom 10% or the bottom 20% people's, how their incomes, how their standard of living. All these things we are going to discuss about income inequalities. Then coming to another important uh, title in this chapter is unemployment. Unemployment. Unemployment, it is a big problem. Unemployment is a big problem in India. Especially in developing countries, the unemployment problem is a big problem. How we can understand what is unemployment? What is unemployment? What are the concepts of unemployment? What are the concepts of unemployment? How we can estimate unemployment? How we can estimate unemployment? There are two ways. There are two ways unemployment can be estimated. Unemployment can be estimated. Then coming to unemployment rate in India. Unemployment rate in India. Unemployment rate in India. Unemployment rate in India. During 1977, 78 to 2011 and 2012. How unemployment rate in rural India, in rural areas, in urban areas and total. Rural area, urban area, in total. Where unemployment rate is high, whether it is in rural area or urban area. In total, how much unemployment? How the trend is changes. Whether unemployment rate is gradually it has been decreasing or continuously it has been increasing. That we have to understand the unemployment rate in India. Unemployment rate in India. And what are the different types of unemployment? What are the different types of unemployment? Types of unemployment. What are the different types of unemployment? Different types of unemployment. In urban area, there are different types of unemployment. In rural area also, there are different types of unemployment. That also we are going to explain in this chapter. Then coming to what is employment and unemployment. What is employment? Employment and unemployment during 1983, 84 to 2011 and 2012. 84 to 2011 and 2012. What is the level of employment and unemployment? Rural, urban and total. Here also we have to see the total population, workforce, labor force, total employees, number of unemployed in percentage. Number of unemployed in percentage. Then finally we have to see in the same chapter that is poverty ratio. Poverty ratio. Poverty ratio. How we can understand poverty? Who are the poor? Who are the poor? Why they become poor? How they come from the poverty? And what steps should be taken in order to come from the below poverty line? BPL, that is below poverty line. How people will get from the poverty? Poverty ratio. Poverty ratio during 1977, 78 to 2011 and 2012. 2012. Poverty ratio. Poverty ratio. How it has been increasing. How it has been increasing. Then coming to poverty line. Poverty gap index. Poverty gap index. Poverty gap index. Poverty gap index, it is the below the mean distance of below poverty line. This also we are going to explain in this chapter. Poverty gap index. Then in this chapter, finally, microfinance. Role of microfinance, eradication of poverty. Eradication of poverty. Role of microfinance, eradication of poverty. Microfinance means it also we will discuss in this chapter. So, in this national income, even though it is an important topic, national income, unemployment, poverty ratio, poverty gap index, and what are the measures to reduce poverty. That is, what is the role of microfinance? How it eradicate poverty from rural India. So these are the things which we are going to discuss in this chapter in details. So far, just I have given an introduction only. Then coming to national income. National income. The definition of national income. What is the definition of national income? National income, it is an aggregate of all factors. National income, it is an aggregate factors which arises from the current production of goods and services. National income, it is an aggregate factor income which arises from the goods and services produced in a country. Aggregate factor means, as we already studied in first year economics, that is microeconomics and macroeconomics. Microeconomics it explains a small parts of an individual. Isn't a small part of individuals. Whereas macroeconomics, it studies aggregates. One individual, one factor, one consumer, one producer, one commodity. All this comes under microeconomics. Whereas macroeconomics, not one individual's income, it is total incomes. Not one individual savings, it is a total savings. Not one commodity, it is total commodity, that is all goods and services. That is aggregates. So therefore, economic principle, it explains rightly that macroeconomics, it studies economy as a whole. Total production, total savings, total consumption, unemployment, poverty, inflation, all these things we already studied in first year. The first chapter. Here, aggregate factor income, which arises from all goods and services by the nations. So therefore, national income is an important economic indicators, economic indicators. Then trends in national income, trends in national income, trends in national income. Trends in national income. Trends in national income. As the CSO means Central Statistical Organization. CSO means Central Statistical Organization. Central Statistical Organization, which was started in 1950. Kendra Gananka Sanstha. Kendra Gananka Sanstha. Central Statistical Organizations. Who is the father of Central Statistical Organization? P.C. Mahalanobis. P.C. Mahalanobis. So here the CSO has furnished national income estimates both at current price and constant price. CSO furnished national income estimates both in two ways. One is current price and constant price. If we calculate national income at current price, it reflects the combined influence of two factors. One is the increase in the production of real goods and services. Increasing production of goods and services, real goods and services. Second one, price rise. Current price, it explains two things. Current price always, it shows that there is an increasing of real goods and services which are available to the people. And second one is price rise. Otherwise, if we calculate national income on the basis of constant price, that is 2004 and 2005. Constant prices, that is 2004 and 2005. Based on the previous years, if we calculate national income, certainly that national income can be a small. National income can be a few. It is a less, because we have to eliminate two things. One is the price rise, that is inflation can be eliminated, and the growth of population also can be eliminated. The major difference is if we calculate national income on the basis of current price always it includes price rise. Inflation will be added in current price. Whereas constant price, if we calculate national income, inflation can be deflator of inflation. Then again, growth of population. If the example, if population increases, national income decrease, what happens? Population increase, national income decreases. What happens to per capita income? What happens to PCI? PCI means per capita income. What happens? National income is decreasing, population are increasing. What happens per capita income? Per capita income will definitely reduce, because the growing population will consume all goods and services. There is no scope for further production. There is no scope for exports. In order to export our goods, our Indians, growing population, they consume all goods and services which produced by agriculture sector, industrial sector, even in service sector. Our incomes, national income is consumed by our Indians. So therefore, population must be eliminated. Inflation must be eliminated. So these two things, if we include in constant price. So the constant price is the important indicator for calculation of national income. National incomes. Then coming to net national product at national income. Net national product at factor cost. Trends in national income. Trends in national income. Net national product at factor cost. Factor cost. Net national product at factor cost. Per capita NNP. Per capita NNP. Per capita NNP. Per capita NNP. Here, the trends in national income. Trends in national income. Net national product at factor cost. Net national product at factor cost. At constant price. At current price. At current price. Year 1950-51. 1991, 2004 and 2005, 2013 and 2014, 2013 and 2014. NNP at factor cost, that is at current price, constant price, current price and constant price. Similarly, per capita income at NNP, Here also we have to see the current price and constant price. Constant price. Current price and constant price. Here we have to see the current price and constant price. So during 1950-51, at current price, the national income is only 9,464 crore. 9,464 crores. It has increased in the year, that is at the time of new economic reforms. It has increased 4,71,619 crore. 4,71,619 crores. Again, it has increased in the year 2000 and 2001, that is 17 lakh 71,118 crores. 18 crores. At the same time, national income at constant price. It is also increasing year after year. Similarly, the per capita income NNP at current price during 1950-51, that is 264 crore, which rose 5,621 crores. 5,621 crore. after the introduction of new economic reforms, after the introduction of new economic reforms, the per capita NNP at current price increased from the increased from the increased from the 5,621 crore in 1991 to 17 lakh 381 crore in 2001. NNP at current prices increased to the 91 lakh 71,025 crore in 2013 and 2014. So in this way, the national income NNP at factor cost per capita at NNP means from 1950-51 to 2013 and 14, the national income at current price it has been increasing enormously, whereas the constant price, the national income increasing slowly. National income is slowly because the constant price it is eliminated of population growth and price rise. Price rise also it has been eliminated. And again in this trends in national income, growth of India's national income, annual average growth rate, annual average growth rate. Annual average growth rate of net national income. Net national income and the per capita NNP and per capita NNP in 2004 and 2005. 2004 and 2005 prices. So if we see the annual average growth rate of net national income and per capita income, how these two have been changing, changes in this plan wise. Plan wise. First 5 years plan when it has started during 1951-56. First plan. Second plan 1956 to 61. Second 5 years plan 1956 to 61. Third 5 years plan 1961 to 66. And fourth 5 years plan period is 69 to 71. Fifth 5 years plan 74 to 79. Sixth 5 years plan 1980 to 85. Seventh 5 years plan 1992 to 97. And again 9th 5 years plan 92 to 97. 10th 5 years plan 97 to 2002. 11th 5 years plan 2002 to 2007. And 12th 5 years plan 2000 97 to 2002. Then 10th five-year plan, 2007 to 2002 to 2007. 11th five-year plan, that is 2007 to 2012. 12th five-year plan, that is 2012 to 2017. 2017. All this five-year plan, the annual average growth of national income, it has been recorded. That first five-year plan, national income, it is 4.2%. 4.2%. The next year also 4.2 years. Second five-year plan. Whereas third five-year plan, it is somewhat, it is 2.6% only. And similarly, the per capita income. Per capita income also, it has been reduced. Only 8th five-year plan, it has recorded 6.7%. 6.7%. Then again, 9th five-year plan, the national income at factor cost, it is 7.5. Whereas 11th five-year plan, 7.8. 12th five-year plan, it is 8.2. But per capita income, it has been continuously declining. Continuously declining. The same, that is the 8th five-year plan, per capita income is only 4.6%. In the 9th five-year plan, 10th five-year plan, it is 5.9. 11th five-year plan, it is 6.3. Whereas 12th five-year plan, it is 6.8. 6.8. By observing this table in your textbook, the annual average net national income has been increasing. At the same time, the per capita income also, in some five-year plan, that is third five-year plan and annual plan, during the Pakistan war and during the China war, the national income and per capita income, it has reduced. It has come down. Whereas recent trends, the national income and per capita income has been increasingly. Then coming to the share of public sector. Share of public sector. Share of public sector means, as we know, the to achieve the objective of socialistic pattern of society, our India is adopted mixed economy during 1948. And so far, there are a lot of industrial policies have been implemented in India. 1948 industrial policy and 1956 industrial policy. There are other industrial policies. In these policies, our Indian government has classified industries as basic industries and key industries. Basic and key industries will be established under government sector, whereas some industries will be established under joint sector. Joint sector means both it is public and private sector. Jointly, they have to invest money and establish different industries in different locations. The remaining industries left to the private people. If we see the share of public sector in India, the share of public sector in India from 1961 to 2011 and 2012. If we see the share of public sector it is in 1950-51, it is only 8%. It is only 8%. The year of 2011 and 2012, it is increased from 8% to 20.2%. Whereas the share of private sector, it has declining from 92% to 79%. 79%. The above table reveals that the public sector in gross domestic product is only 8%, but it has increased to 23.6% in 1990s. So it shows that there is an importance given to the public share, public sector. A lot of in this it shows that the importance was given to the public sector by the government of India. Public sector to the government of India. Then coming to the share of organized and unorganized. The share of organized and unorganized. Organized and unorganized means the share of organized and unorganized. Organized and unorganized. The share of organized and unorganized. What is organized and what is unorganized? What is organized and what are unorganized? The best way, industrial sector and service sector is the best example for organized sector, because in an industry always workers they go for works, they have maintained some records and also annual reports they have to prepare. Then there is a balance sheet will be there. Whereas unorganized sector, where there is no constant keeping of records and accounts, if there is no balance sheet, those can be unorganized. In a systematic manner, if we see, the organized has defined by CSO, that is Central Statistical Organizations. All enterprises which are either registered or come under the purview of any act and maintaining annual accounts and balance sheet. These are all organized sectors. Whereas unorganized sector is defined as which are unincorporated enterprises and household industries other than the organized. Households and private individuals who are not maintaining any accounts and don't have any balance sheet will be called as unorganized sector. The share of unorganized sector has risen from 30% to 42% during 1980s to 2007 and 2008. Consequently, the share of unorganized sector declined from 70% to 57% during the same period. So this is all about organized sectors. Organized and unorganized sectors. Then coming to income inequalities. It is very, very important thing. Income inequalities in India. So in India, the distribution of income is one of the major problem. Distribution of income is one of the major problem in our planning process. The main objective of economic planning is to reduce income inequalities. The main plan of our objective is to our plan is the reduce income inequalities to maintain social justice. To reduce income inequalities, maintain social justice. There is an extreme concentration of economic wealth. There is an extreme concentration of economic wealth in the hands of few individuals. Those are industrialists, landlords, and business people. There is an extreme inequalities of land and assets and other things. The income inequalities in India have highlighted by different reports. The income inequalities have been highlighted by different institutions, different research organizations and individuals. They have conducted different studies on the basis of national income. They have estimated national income in the different methods. So, estimation of national income. There are 4 important institutions. Estimation of national income. First one is LIDOR and NCAER. NCAER estimates 1950s. NCAER LIDOR is an individual, whereas NCAER means National Council of Applied Economic Research. National Council of Applied Economic Research. These people, they have estimated national income during 1950s. During 1950s, they stated that the top 10%, top 10% of households had received about 35%. Received 35% of assets. 35% of national income. Top 10% of individuals, they are receiving 35% of national income. So, it shows that how inequalities are existed in India during 1950s. And another estimation also, it is made clearly. Second one is NCAER, OZA and VB Butt. NCAER, OZA and VB Butt. These 2 are in individuals, whereas NCAER it is an institution. National Council of Applied Economic Research. These people, they have estimated during 1960s on the basis of personal income. Their estimation, that is bottom 20%. Bottom 20% of people had share of 7.5%. 7.5%. Bottom అట్టడుగు ఉన్నటువంటి వాళ్ళు 20% of people, they are only having 7.5% income. 7.5% incomes. Whereas top of the people, their share is top 10% of the people, their share of income is 42%. 42% of national income, personal incomes. So very few people, they are having lot of income. More people, they are having less incomes. And another study, very interesting, that is NSSO. NSSO also, they have studied that NSSO, National Sample Survey of Organization. National Sample Survey of Organization. So these people, they have studied during 1973 and 74. The lowest 20% of households accounts for 9.5%. The lowest 20% of households, they are only having 9.5%. 9.5%. 9.5% of total consumption. Lowest 20% people, they are having 9.5% of consumption, whereas in rural areas, the highest 20%, highest 20% of the people, they are having nearly 38%. Highest 20% of people, 35% of consumption they are enjoying. Then another important study, it is that is Institute of Applied Manpower Research. Institute of Applied Manpower Research. Institute of Applied Manpower Research. They have studied that in India, the distribution of assets is extremely unequal. The distribution of assets is extremely unequal. With the top of 5% of households, 5% of households, they are possessing nearly total assets. In the bottom 60% of households, they are only having 13%. 5% people, they are having total assets. The bottom of 60% people, they are only having 13% of assets. So, by looking or by observing all these four estimations with regard to inequalities in national income, we can understand that how inequalities of national income in India are existed. It is very serious thing, that is inequalities in India are existed. So thank you very much for giving me this opportunity. So the remaining part we will discuss in next class. Thank you.
Good morning all of you. This is Sri Tulasi from KGBV Sitanagaram, Vijayanagar district. Today I would like to explain about electrochemistry. Before we learning about electrochemistry, first of all we will know about what is electrochemistry. We keenly observe the title of the topic. It consists of two words. First one is electro and second word is chemistry. We know that the word electro deals with electricity or electrical energy. The second word chemistry deals with, we know that it deals with chemicals or chemical energy. Chemicals or chemical energy. What do you observe? That two words deals with both electrical energy and chemical energy. So what is electrochemistry? Electrochemistry is a branch of chemistry. It is a branch of chemistry. It deals with the relationship between electrical energy and chemical energy. What is electrochemistry? Electrochemistry is a branch of chemistry. It is a branch of chemistry which deals the relationship between the relationship between both electrical energy and chemical energy. So what is electrochemistry? Electrochemistry is a branch of chemistry. It is a branch of chemistry. It deals with the relationship between the electrical energy and chemical energy. So to understand this, I would like to show a picture to understand what is electrochemistry, what it deals. Okay. What do you see in the picture? In this picture, we saw a battery with a bulb which is connecting through a wire. What do you observe? The bulb can be blows. How the bulb can be blows without passing electricity? Because there is a chemical energy behind the battery. That chemical energy is used to blow the bulb. Here, what we can say, the chemical energy is converted to electrical energy here. This is the phenomena we can use in electrochemistry. What is electrochemistry? Electrochemistry is a branch of chemistry which deals with the relationship between electrical energy and chemical energy. What it means? The electrical energy is converted to chemical energy and the chemical energy is converted to electrical energy. Before we learning about electrochemistry, first of all we will know about what are the keywords involved in electrochemistry. So we must learn those keywords. So what are they? They are conductor, insulator, electrolyte and non-electrolyte. What is conductor? Conductor is a substance which allow the passage of electricity through it. Then those substances are known as conductors. What are conductors? The substance which allow the passage of electricity. Electricity through it. Then those substances are known as conductors. Example, all metals are conductors. Those are copper, iron, and we have number of metals in our daily life. We are using number of metals. So example, all metals. All metals are conductors. And what is insulator? Insulator is a substance which does not allow the passage of electricity through it. So here, what is insulator? The substance which does not allow the passage of electricity through it. Does not allow the passage of electricity through it. Then those substances are known as insulator. Here we have wood, plastic. These are the insulator, examples of insulator. Example, wood, plastic, cloth. So these are the examples of insulator. They are not allowed the passage of electricity. We know that the cooker handles are made up of that insulate plastic. That is plastic, and the current wise is covered with plastic cover. So here what we can observe, They are insulator. They act as a insulator. So what we can observe, the screwdriver handle is made up of plastic. So they are not allow the passage of electricity through it. Now we will go for what is electrolyte and what is non-electrolyte. What is electrolyte? Electrolyte is a substance. If the substance is able to pass electricity through it, either in molten state, aqueous state or fused state, those substances are known as electrolytes. What is electrolyte? What is electrolyte? If the substance able to pass electricity either in molten state or aqueous state or in fused state. Fused state is known as electrolyte. What is non-electrolyte? What is non-electrolyte? If the substance unable to pass electricity either in molten state or aqueous state is known as non-electrolyte. What is non-electrolyte? Non-electrolyte is the substance. If the substance unable to pass electricity through it either in molten state or aqueous state, that is known as non-electrolyte. What is non-electrolyte? What is non-electrolyte? If the substance unable to pass electricity either in molten state or in aqueous solution state is called non-electrolyte. What is the example of electrolytes? So we know that electricity is nothing but flow of ions. Flow of ions is known as electricity. Here the substance which is having ions, those substances are able to allow the passage of electricity. So acidic substances, alkali substances, acidic solutions, alkali solutions, fused NaOH, HCl, H2SO4, these are the number of examples of electrolytes. Electrolytes examples: acidic solutions, alkali solutions, fused NaOH solutions, etc. So these are the electrolytes. What are the examples of non-electrolytes? So the substances which are not having ions, those substances are non-electrolytes. Here, what is the example of non-electrolyte? They are distilled water. Distilled water not having any ions. So the mobility of ions is not takes place in distilled water. So that is a non-electrolyte. And paraffins and oils, these are the examples of non-electrolytes. What do you see in the picture? In this picture, we observe two containers here. The first container contains the solution of electrolyte and the second container contains the solution of non-electrolyte. So, in the first container, what we can observe, the bulb can be blown because in the solution there was a present of ions here. So here in the second container, the bulb cannot be blown because they are not having any ions in that solution. So that is a non-electrolyte. Now we already know that what is conductor, what is insulator, what is electrolyte and what is non-electrolyte. These are the basic terms to understand what is electrochemistry and to learn about electrochemistry. Here now we will go for electrochemical cell. Electrochemical cell. Now we will go for electrochemical cell. Nowadays electricity can be produced in several ways, in several power plants with several sources. Here in the case of thermal power plants, the source coal can be heated at high temperatures and that can be produced as steam, and that steam can be activate the turbines to rotate. Here that turbines can be produce mechanical energy, and that mechanical energy another converted into electrical energy. In the case of solar power plants, what we can observe, the photons can be absorbed by the solar plates and it can be produced as steam. That steam can be activate the turbines to rotate. That mechanical energy another converted to electrical energy. In the case of nuclear power plants, what we can observe, nuclear fission reactions are observed and it can be produced a steam. That steam can be produce a mechanical energy because the turbines can be rotated, and that mechanical energy another converted into electrical energy. And in the case of hydraulic power plants, what we can observe, the tidal power which is present in the hydraulic power plant, the tidal power is activate the turbines to rotate and that can produce a mechanical energy, and that mechanical energy another converted into electrical energy. Here these are the same phenomena observed in all power plants. So here electricity can be produced, the indirect conversion of that is the mechanical another converted to electrical energy. The source energy can be converted into mechanical energy, and mechanical energy another converted into electrical energy. Here the direct conversion and the another method to produce electricity is known as electrochemical cell. Here what is electrochemical cell? Electrochemical cell. What is electrochemical cell? Here electrochemical cell is a device. It is a device which convert chemical energy to electrical energy. That converts chemical energy to electrical energy by using spontaneous redox reactions. Spontaneous redox reactions. What is electrochemical cell? Electrochemical cell is a device which converts chemical energy to electrical energy by using spontaneous redox reactions. Here, what is spontaneous? Without applying an external force. The reaction can be done without applying external force is known as spontaneous. Spontaneous. Here, what is redox? The word redox consists of oxidation and reduction. What is oxidation? Loss of electrons is known as oxidation, or if the oxidation number increases, that is also known as oxidation. Here, what is reduction? Reduction is nothing but gain of electrons. Gain of electrons is known as reduction. If oxidation number decreases, then we can call it as reduction. If the oxidation and reduction takes place simultaneously in the reaction, then those reactions are known as redox reactions. What is redox reactions? If the oxidation and reduction takes place simultaneously, that means that those are the reactions, the oxidation reaction and reduction reactions takes place in the same reaction is known as redox reactions. For example, we have to take the oxidation redox reaction of the zinc and copper. What we can observe, zinc plus aqueous solution of copper, that is Cu plus 2 aqueous, that is a solid form. Zn plus Cu plus 2 in aqueous, it will forms, what is that? Zn plus 2 aqueous plus copper solid. Here what will happen? If the oxidation number of the zinc here is 0. The oxidation number of zinc here is 0. What is the oxidation number of zinc here? Plus 2. That means the oxidation number can be increases here. If the oxidation number is increases, what it called as? That is oxidation. This is oxidation. Here in the same way, the oxidation number of copper here plus 2. Here the oxidation number of copper is 0. That means the oxidation number is decreases. So that is known as reduction. That is known as reduction. Here the oxidation and reduction takes place in a same reaction. That means the oxidation and reduction takes place simultaneously. Then those reactions are known as redox reactions. Here what we will observe, the oxidation number increases and they loses 2 electrons here. They loses 2 electrons here. Zinc loses 2 electrons, it will forms Zn plus 2, and copper gains 2 electrons. Copper gains 2 electrons here, that is copper gains 2 electrons. So that undergoes reduction. This is the example of redox reaction. Now we will know how many types of electrochemical cells. Generally, electrochemical cells are 2 types. Electrochemical cells are 2 types. First one is galvanic cell or voltaic cell. Second one is electrolytic cell. What is galvanic cell? Galvanic cell is a electrochemical cell. Here the chemical energy is converted to electrical energy. Here by using spontaneous chemical reactions. Spontaneous chemical reactions. Here what is electrolytic cell? In this cell, this is the electrochemical cell. Here the non-spontaneous reaction can be occurred when electricity passing through it. When the electricity passing through the cell, electricity is passing through the cell, the non-spontaneous reaction can be occurred. Reaction can be occurred. Here the negative electrode is used in galvanic cell. The negative electrode is used as a anode and the positive electrode is used as a cathode. In the case of electrolytic cell, the negative electrode is used as a cathode and the positive electrode is used as a anode. So what is galvanic cell and what is electrolytic cell? Electrochemical cell can be classified into 2 types, galvanic cell and voltaic cell or electrolytic cell. In the galvanic cell, the chemical energy is converted to electrical energy by using spontaneous chemical reactions. Here in the galvanic cell, the chemical energy is converted to electrical energy by using spontaneous chemical reactions. Here in electrolytic cell, the the non-spontaneous reactions can be occurred while the electricity passing through it. Okay, here the negative electrode is used as an anode. In galvanic cell, the negative electrode is used as an anode and the positive electrode is used as a cathode. Here in electrolytic cell, the negative electrode is used as a cathode and positive electrode is used as a anode. Now we will go for galvanic cell or voltaic cell. What is galvanic cell? Galvanic cell is an electrochemical device. It converts chemical energy to electrical energy by using spontaneous chemical reactions. Spontaneous redox reactions. Here, the setup consists of zinc rod dipped into a zinc sulfate solution. Here, it is dipped into a zinc rod is dipped into a zinc sulfate solution. Here, in the zinc can be present in zinc sulfate as a Zn plus 2 and SO4 minus 2. Here, and copper rod which is dipped into a copper sulfate solution. Copper rod dipped into a copper sulfate solution. Here also, copper in the form of Cu plus 2 and SO4 minus 2. Here there is a two zincs are there. One zinc is in the form of zinc solids, zinc metal, and second zinc is aqueous form of the zinc. Here the oxidation number of a zinc is here 0. And the oxidation number of zinc present in the solution is Zn plus 2. Here, the two zincs are jealous to one another. What will happen? The zinc can be dissolution into Zn plus 2. It loses 2 electrons to convert, likely convert to Zn plus 2. Here, zinc is likely convert to Zn plus 2 and Zn plus 2 is likely convert to zinc here. That means the dissolution takes place and deposition takes place here. What will happen? Zinc is in a solid form. Zinc loses 2 electrons. It will form Zn plus 2 here. And copper, and here Zn plus 2 takes 2 electrons. It will form zinc here. The reversible reaction occurs here. Here we know that the loss of oxidation is known as, the loss of electrons is known as oxidation, we know that, and the gain of electrons is known as reduction. Here, after some time, the dissolution and deposition takes place continuously. After some time, it will get equilibrium. Here, the charge difference we can observe. Here, the potential can be, the negative potential is observed in the electrode. The negative potential is observed in the electrode. That is a single electrode potential. We cannot determine the single electrode potential here. We must have reference electrode to find out the single electrode potential. So here there is some negative energy, the negative potential developed here. In the similar way, what will happen? The copper rod is dipped into a copper sulfate solution. Here there is a 2 coppers are there. The copper is with oxidation state 0 and the copper with oxidation state plus 2 here. Here similarly in the same way, the copper can be Cu plus 2 takes 2 electrons and it will turns into a Cu, and Cu also loses 2 electrons, it will turns into a Cu plus 2 here. So what is it is reduction and this is oxidation takes place here. What will happen? They are in a dynamic equilibrium. Here also the potential is developed due to the charge difference. The potential is developed. This is a single electrode potential. We cannot determine it. Here, after connecting, before connecting to this, here what will happen? They are having the deposition and dissolution takes place here. What will happen? They are in a equilibrium position here. They do not disturb the equilibrium. And here this is also there is an equilibrium. When it is connecting to through the voltmeter, what will happen? The electrons can be here. The zinc rod loses 2 electrons continuously, and it will gives from the zinc rod the electrons that travels from the zinc rod and it will goes into a copper rod here. What will happen? Only the oxidation takes place here. The reduction is prevented. Why? Because they are having more negative charge density we can observe. Due to the more negative charge density, the reduction can be prevented here. What will happen? The copper rod likely to take electrons from the zinc rod and they are not oxidized. So here the oxidation can be prevented here. So here the zinc cell acts as a oxidation half cell. Here the cell which is undergoes oxidation is called, that is oxidation half cell. It acts as a anode here. The negative charge we can observe, it acts as a anode. Here what will happen? In the copper rod, they undergoes only reduction. Here this acts as a reduction half cell here. And it acts as a cathode here. It gets positive charge. Here, after some time, what will happen? That continuous reaction, that means the transfer of electrons continuously from zinc to copper. What will happen? The oxidation is continuously takes place here. The deposition of a Zn+2 ions is happen here. The more number of Zn+2 ions are present in the solution. Here the mass of the zinc rods can be decreases. Here the mass of the copper rod can be increases. What will happen? Here the more number of zinc rod is, the more number of Zn+2 ions is in the zinc sulfate solution. What will happen? There is no space to convert zinc to Zn+2 here. That means the oxidation cannot occurs here. The reaction can be stopped here. And here the oxidation can be stopped. Then they are not having they are not ready to give electrons to the copper rod, so the reduction can be prevented here. So to prevent this, we must have salt bridge. Salt bridge. What is salt bridge? That is a inverted glass tube which is connecting to the both half cells, which is having NaCl or KCl salts with agar-agar paste. To prevent this, the glass rod contains NaCl or KCl salts. Here with agar-agar salts it solidifies, and what will happen? The extra zinc Zn+2 present in the oxidation half cell, the extra Zn+2 present in the oxidation cell nullified by here the chlorine, that means Zn+2 ions can be nullified by the chlorine ions which is coming from salt bridge. here, and the extra SO4 minus ions present in the copper, that means reduction half cell, can be nullified by using sodium or potassium. Sodium or potassium ions, the cations can be nullified. The number of SO4 ions present in the reduction half cell. So the internal circuit can be completed. So the reaction can be continuously occurring. The reaction can be continuously occurring, and here if we use a normal glass tube here instead of salt bridge, what will happen due to the capillary property, the solution can be mixed up. Due to prevent this, we add agar gel with NaCl or KCl salt. Here we use salt bridge like this. Here, what is the total reaction here? The final reaction is at cathode. What is the reaction we can observe? At anode. Here at anode, what is the reaction? Zinc losses only. In the oxidation half cell, what we can happen? Zinc losses 2 electrons. It will form Zn plus 2 electrons. Here at anode, at cathode, what will happen? Copper takes, Cu plus 2 takes 2 electrons. It will form copper. This is in a solid phase, this is in an aqueous phase, and this is in an aqueous phase, this is in a solid phase. What is the final reaction here? The 2 electrons are cancelled. 2 electrons are cancelled both sides. What is the final reaction here? Here the final reaction is Zn plus Cu plus 2 gives rise to Zn plus 2 plus Cu. That is a zinc in a solid phase, copper in a aqueous phase. Here zinc in a aqueous phase and copper in a. Here the zinc and copper 2 rods are there. Here the anode part zinc rod is which is dipped into a zinc sulfate solution. Here the zinc sulfate solution, the zinc can be in the form of Zn plus 2 and SO4 in a SO4 minus 2. Here similarly the cathode part copper is dipped into a copper sulfate solution, and in the copper sulfate solution copper can be in the form of Cu plus 2 and SO4 minus 2. Here there is a porous sodium or potassium chlorine salt bridge are there. Here contains sodium ions and potassium ions. Here the zinc, the 2 electrons of zinc can be travels from zinc to copper. Here the electrons can be traveled from anode to cathode here, and the oxidation takes place in this oxidation half cell. The zinc rod loses 2 electrons and can be dissociated into Zn plus 2 here, and the mass of the zinc rod can be decreases. In similar way, the mass of the copper rod can be increases by gaining of 2 electrons, which is coming from the zinc electrode here. And here the excess of SO4 solution, the excess of SO4 ions can be neutralized by the ions, the sodium ions, sodium or potassium ions, which is coming from the salt bridge. It can be neutralized by sodium ions. The SO4 ions can be neutralized by sodium ions coming from the salt bridge, and the excess of Zn plus 2 ions can be neutralized by the chloride ion, which is coming from the salt bridge here. So the reaction can be continuously processing here. So the continuous and this total reaction is like that. Cu plus 2 plus Zn gives rise Zn plus 2 plus Cu. Now the cell representation of a galvanic cell is cell representation of a galvanic cell is here. What is that? Here Zn, this is the representation of oxidation half cell, and 2 vertical lines indicates the salt bridge, and here copper plus 2 to copper. Here What is the phases here? Zn in a solid phase and Zn plus 2 in a aqueous phase and copper in a aqueous phase and copper in a solid phase. Here this is the cell representation of galvanic cell here. What is that? This indicates Zn to Zn plus 2 here indicates oxidation half cell. Oxidation half cell, and here the two vertical lines indicate salt bridge, and here Cu plus 2 by Cu here Cu plus 2 to Cu indicates the reduction half cell. This is the cell representation of galvanic cell. Is E oxidation is nothing but E cathode, E anode. It can be represented by E Zn by Zn plus 2. Here that is oxidation potential here. And the reduction potential is E reduction is equal to E cathode. E cathode, that is E Cu plus 2 by Cu here, that is redox potential here. So here this is a solid phase, this is aqueous phase, this is aqueous phase, and this is solid phase. Here at a standard conditions, what is standard conditions? Here the temperature is equal to 25 degrees or 298 kelvins and pressure is equal to 1 atmosphere and concentration is equal to 1 molar. At a standard condition, here the E oxidation is known as standard oxidation potential, that is nothing but SOP here, and standard reduction potential is called E0, that is reduction potential is called, that is standard SRP here, standard reduction potential. So the potential difference we can calculate here. We can calculate only the potential difference. We cannot calculate single electrode potential. If we calculate single electrode potential, we must have reference electrode to calculate the single electrode potential. Here we can calculate only the potential difference here. The potential difference we can observe in difference. The potential difference, that means that is nothing but E cell can be observed here is equal to E cathode minus E anode. Here by experimentally by using standard electrode potential, the standard hydrogen potential, E cathode can be calculated in a galvanic cell is plus 0.34, and here E anode can be represented by minus sign. It indicates the electrons transfer, that is the electrons loss of electrons, that can indicate the minus sign is indicates the oxidation. Here the oxidation indicates the minus sign. Here E anode can be calculated by 0.77 volts. Here E cell of the galvanic cell can be measured as 0.01 volts. This is about the galvanic cell. Here now we will go for standard electrode potential. We already know that we cannot determine the single electrode potential because oxidation and reduction reactions cannot occur alone. We cannot determine the single electrode potential. I already told you na. We cannot determine the single electrode potential. We can calculate the potential difference of the two electrodes. Here to calculate the single electrode potential, we must have the standard electrode. That is in standard electrode, here normal hydrogen electrode is used as a standard electrode. Hydrogen electrode or standard hydrogen electrode is used as a reference electrode. To calculate the standard electrode potential here. Here, what is the standard electrode potential consists of? Here, in a standard electrode, there is a inverted U tube here. That in the inverted U tube, they have a platinum wire which consists of a platinum plate, and this is dipped into a 1 molar concentrated H2SO4, 1 molar HCl, 1 molar. Here it is dipped into a 1 molar HCl solution. Here the 1 atmospheric pressure H2 gas can be introduced here. What will happen here? The H2 is in a gaseous state, that is in a gaseous form, and here the HCl, the hydrogen ions present in the HCl is in the form of H plus ions. Here, we can observe the H2 losses 2 electrons. The H2 losses 2 electrons and it will turns into a H plus. Here the charge difference we can observe. The bubbling we can observe here. It turns into a H2 losses 2 electrons. It will turns into a 2H plus 2 electrons. That is oxidation. We know that. And reduction reaction is also occurred in this electrode. In the same electrode, what we can observe here, H plus 2H plus 2 electrons gives H2. Here the reduction reaction is also occurred. Here the oxidation and reduction reactions both are occurred in a same electrode. So we can assume that the potential difference, that means the electrode potential is taken as 0.00 volts. Here this is the standard electrode potential. Here this is the standard electrode potential. The standard hydrogen electrode is used as a normal hydrogen electrode is used as a standard electrode to determine the potential of the single electrodes. Here we can take it as a reference electrode to calculate the potential differences of potentials of the different electrodes. So here to determine the different potential difference, different electrode potential of different elements, the electrochemical series can be arranged. What is electrochemical series? Depending upon the standard reduction potential values, we can arrange the elements. We can arrange the elements depending upon the standard reduction potential values. We can arrange the element in a series. That is called electrochemical series. What is electrochemical series? What is electrochemical series? That is the arrangement of elements by the increasing order of their tendency to lose electrons. They are called electrochemical series. What is electrochemical series? Electrochemical series is the arrangement of elements in the increasing order of their tendency to lose electrons. That is known as electrochemical series. Here the elements with negative SRP values. The negative SRP values, they act as a anode with respect to standard hydrogen electrode. Here, what is that? The elements which are having negative SRPs, it acts as an anode with reference to standard hydrogen electrode. Here, and the elements which are having positive SRPs, positive standard reduction potentials, they act as a cathode here with respect to standard hydrogen electrodes. Here, the elements which are having high oxidizing agents, the elements which are acts as high oxidizing agents, they are placed in a below the hydrogen present in the electrochemical series. and they are having positive value. Here the elements which are having high, acts as a high reducing agents, they are placed as a above the hydrogen standard hydrogen electrode potential. Here in a above the hydrogen they are having in a negative sign. They are having in a negative sign. Here this is about electrochemical series. I show the electrochemical series. As I told you, the elements which are having high reducing power, they are placed in a above the hydrogen, and the elements which are having high oxidizing power, they are placed in a below the hydrogen. Now let us come to know NS equation. The chemist NS, they give the equation about the relationship between, it is the relationship between, the next equation is the relationship between the electrode potential and concentration of the cell is known as Nernst equation. What is Nernst equation? Nernst equation is the relationship between the electrode potential and concentration of the cell is known as Nernst equation. The Nernst equation, for example, in general electrode, in general electrode we consider as reaction, the electrode reaction is Mn plus 2 plus N electrons gives M. Here this is a aqua phase, this is a solid phase. So what is the, according to Nernst equation here, according to Nernst equation here, what is that? It indicates E Mn plus 2 by Mn M. Here it is in an aqueous phase, it is in a solid phase. It indicates the cell potential that is equal to E naught, that is standard cell potential E naught Mn plus by M. Here aqueous, that is solid. Here minus 2.303 RT by NF log concentration of metal by concentration of aqueous solution of a metal. Here this is about the Nernst equation of a general electrode. We know that here, we know that the concentration of the metal we can take it as a 1, because the concentration of metal general we can add solid or liquid. The concentration of a pure metal we can take it as 1. So what is the E Mn plus M? Here E Mn by M indicates electrode potential. Here E naught Mn plus by M indicates standard electrode potential. Here R is a gas constant. That value is 8.314. Here T is equal to temperature. Temperature is in a 25 degrees Celsius or 298 kelvins. Here M that is concentration of a metal. M indicates concentration of a metal, and the Mn plus 2 concentration indicates the concentration of ions. Here we know that the pure metal concentration we can take it as 1. Here what is that? The reaction is E Mn. So the Nernst equation is like this. Mn plus is equal to E naught Mn plus by M is minus 2.303 into 8.314. Here 8.314 into temperature 298 kelvins by N into, here F is equal to 1 Faraday. 1 Faraday means 96,500 coulombs. 96,500 coulombs log 1 by M N plus aqueous concentration. Here Nernst equation is finally, that is E indicates electrode potential. E is equal to, here it is electrode potential is equal to E naught is indicates standard electrode potential minus 0.059 by N log 1 by concentration of Mn plus aqueous. This is the Nernst equation. It is used for the it is indicates the relationship between the electrode potential and concentration of the cell. Okay, thank you.